Let's add a few more details to how the oil spills can be cleaned up. Okay, there are companies that actually make big money out of this business of cleaning up oil spills. Nonetheless, as we already saw, natural seeps account for almost 47% of the oil that gets into the ocean, but those seeps are typically very small. But the human sources include just the consumption, so the transportation, so it's the leaks that we don't even think about. Transportation, the oil tankers crashing and releasing this mess, is only about 22%, but visually they are the most shocking because they release millions of gallons at one time and create lots of very bad images, right? And petroleum extraction, so wherever they are being drilled, there is a lot of leakage into the groundwater, into the coastal oceans, and so on and so forth, which is also about 6%. How does it work? Just if you leave it alone, oil in the water column tends to float. With photolysis and so on, there is some oxidation. The heavier parts coagulate into drops, and then they sink out to the bottom. And then there is a mix-up from the oil reservoir if it is deeper in the ocean, so it's a natural seep. So you can create a slick just from the natural seep as well. So you can either release by the tanker accident or a leak from the transportation, or it can come up from the bottom. Eventually, there is an emulsification, so light petroleum hydrocarbons tend to evaporate. As I said, the Houston air quality was affected by evaporation of the Deep Horizon spill that happened over the Gulf of Mexico. Warm air, evaporation is higher. Lighter hydrocarbon evaporates faster. And eventually, it forms some kind of a mousse, and the heavier parts can here sink out. And if it sinks to the bottom, it's pretty safe because over time it gets consumed by these microbes that can eat the hydrocarbon. So bioremediation, as I said, is a way that cleaning up of oil spills happens. Bacteria released intentionally into the marine environment, or you can create conditions. So you don't necessarily throw tons of bacteria, but you create conditions that stimulate the growth of these naturally oil degrading bacteria. We make a mess, but we need to find a way to clean it up. Sometimes we are good at finding ways to do that, but preventing oil spills itself then becomes critical. So Oil Pollution Act of 1990, as I already mentioned, mandated that single-hulled tankers cannot be operating, at least coming into the US ports. They cannot even come within the exclusive economic zone type area, 320 kilometers in France and Spain. So forget the ports, they cannot even come near. Double hull tankers are now quite normal, because if you want to sell your oil, you need to redesign your ship. Sometimes, like this was a Japanese tanker that crashed off of Oregon. There was not much to be done. Some of the oil was swept up. Some of the oil was allowed to burn, some of it was intentionally set on fire. Eventually the tanker split into half and sank to the bottom of the ocean. Okay, so is that a legitimate way to do it? Not really. It just depends on what situation you are facing and whether there is a way to actually rescue the oil, sweep it up, and reuse it, or take it and dump it safely, and so on. So sometimes just burning it in the open ocean can be a legitimate way to get rid of it. Okay, so this continues to be a problem as long as there is massive amounts of oil being shipped around. It's always going to be a concern. So rules and regulations are there, ship designs are there, and hope that the next accident is not going to happen anytime soon, right? That's always the hope.